Hello everyone, my name is Mehdi and I'm representing Make Blockchain Green. We're here this evening to talk about an environmental issue that we feel is of great importance. Our objective today is not to try and persuade you to take a stand, but we would like to try and present both sides of this issue in order to better educate the public on a very important concern. We want to take this opportunity to thank the GatherVerse community for allowing us to come before you today for this Web3 Summit. Our topic today is how to actually make blockchain green. We're going to have a little chat about energy consumption, the consensus mechanism. We're going to have an overview of the top 4 blockchain used for NFT minting and their carbon footprint. And we're going to see how to make it green with the help of the Green Chain Score. GM everyone, I'm an energy engineer and I work in French companies in sustainable finance and blockchain and NFTs. And today I'm speaking as the founder of MBG, Make Blockchain Green. And our aim is to make sustainable blockchain for all. And our mission is to bring energy efficiency standards to the blockchain ecosystem. And in order to achieve that, we are creating the first ecolabel for blockchain project called the Green Chain Score, and we're going to talk about it later in the presentation. But first, why blockchain is becoming bad for the environment. As you can see, Bitcoin has country level consumption compared to Norway, Bangladesh, or Switzerland, and the energy needed to make a unit dollar is cheaper than the usual way. So it's still cheap for what it's supposed to fix, for example, banking and storing of value, but we still have areas of improvement to reduce this energy consumption. The question is why the blockchain is so energy intensive, and this is because of the consensus mechanism. We can distinguish between proof of work, proof of stake, delegated proof of stake, and proof of history. But blockchain is all about building digital trust. So blockchain networks rely on consensus algorithms to reach agreement among various users. And for example, if you buy one Bitcoin and transfer it to your wallet, everyone else must agree that you own the Bitcoin. And if they didn't, your currency would be worthless. So in order to do that, the miners, which are the main actors of blockchain ecosystems, are competing through very complex algorithms, to riddle this complex challenge and get the next block and get the reward at stake. So if we remove this element of competition, it could save energy, and this is which is mainly used in proof of stake algorithms, and we're going to see later how it's work. Basically, the difference between proof of work and proof of stake is the consensus mechanism. But as you can see, the energy consumption is really different. Whereas in the proof of work, we are talking about terawatt hours, industry grade level energy of consumption. For the proof of stake blockchains, we're talking about megawatt hours, and even for the lowest kilowatt hours. But we still have areas of improvement in order to reduce or to offset that energy consumption and that carbon footprint. When we talk about the 4 main blockchain for NFT minting, we have the energy cost to mint one NFT in the Tezos blockchain, which is a proof of stake, which is really low. We're talking about milliwatt hours, whereas in the Ethereum and the Bitcoin, we're talking more about a few hundred of kilowatt hours, and for the Solana, only 3 watt hours, which is really low. And this is only concerning the minting operation for this energy cost. We're neglecting the bid, the sell, and the transfer transaction, which are way energy intensive. Let's talk about the carbon footprint of all this energy used. As we can see, we can compare Bitcoin to American Airlines and approximately 3 Nikes. And there is a thing we're not talking that much about when we think about the carbon footprint of blockchain is the electronic waste, because there is a hardware race between the miners, and you have to every year change the hardware to be the more efficient, the more competitive. So we can also consider the carbon footprint of this electronic waste, and also e-waste per transaction around 340 grams, which is equivalent to 2 iPhones. And we can compare that to the proof of stake carbon footprint, which is more easy to understand, because if you take a round trip between Munich and San Francisco, um, and this data is made by the Crypto Carbon Rating Institute. So we can say that 9 round trips from Munich to San Francisco in business class emit about the same amount of carbon dioxide than the Tezos network. So basically, this is not really compared to Bitcoin, but I think there is also areas of improvement. So basically, how to make it green? I can distinguish between different solutions, graded by the impact and the effort. We can shift from proof of work to greener consensus algorithms, and we can also optimize the electrical consumption of the hardware used. Another way to generate electricity by recycling wastes from other industries. We can use, for example, wasted energy such as flared gas in energy production. We can also use server farms, machines in cold countries and or powered by renewable energy, just like in Salvador with the volcano. And we can also offset the carbon footprint by buying carbon offsets. And of course, we can also use the green chain score. So let's talk about the green chain score. The green chain score is the first eco label for blockchain. So basically, this is the first decision support tool that helps you get an overview of your blockchain investments carbon footprint across through audited projects. And with the GCS, you can actually decide that your Web3 journey is going to be sustainable. And our methodology is quite simple but yet effective. The green share score is made of the minting analysis plus a bonus malus system. We can distinguish between the consensus mechanism, the layer 1 platform used, the energy cost per transaction, but also new criteria voted by the DAO. And we can have also bonuses and maluses such as carbon offsetting, insetting, and smart contract optimization, and also DAO proposals. And all of this led to a score of 100. And basically, this is the NFT projects audited so far. As you can see, they're both Ethereum NFT projects powered, and they're the grade E, and it's scaling from 0 to 100, and there is more to come. So yeah, I'm not gonna say that much today, and I'm just gonna thank you for your attention. And if you have any questions, the chat is open. If you have questions about energy consumption,